Okay, hello and welcome to section 2.2 video. In this video I explain the purpose of static routes and how to configure them. For this video I've also uploaded the demonstration packet tracer file on Netherkit under section 2.2. You can download the file and follow through with the commands. Static routes are configured using the IP route global configuration command. The basic syntax for the command is shown here. If we look at the syntax here, the keyword here is IP route, and then followed by several parameters that are required in order for us to configure static routing. Okay, so first we have the IP route, the keyword, the main command IP route. The next parameter is the network address. Now the network address is referring to the destination network address of the remote network that needs to be added to the routing table. Often this is referred to as the prefix. As we go through, we'll notice that this is referred to as the prefix. And then we have the subnet mask, or just the mask of the remote network to be added to the routing table. And the subnet mask can be modified to summarize a group of networks here. And then we have the third parameter. One or both of the following parameters here can be applied or must also be applied. That's the IP address of the connecting router to use to forward the package to the remote destination network. This is commonly referred to as the next hop. And then we have the outgoing interface to use to forward the package to the next hop. Okay, so notice that as we go through this video, we're going to be looking at either configuring a static route by using just the IP address only, or by using the exit interface, or we could use both of them. Okay, so we'll be looking at three common ways of configuring static routes, and we'll discuss them in this video. The last one, the distance parameter, it's just basically used to create a floating static route by setting an admin distance that is normally higher than a dynamically length route. Remember, a floating static route is purposely used as a form of a backup route. Whenever the primary route fails, the backup will kick in, which is usually the one with a higher admin distance than the one that is lent by the dynamically lent route, okay, whether it's OSPF or EIGRP. Okay, so I'll bring up the packet tracer file. Like I said earlier, you can download this packet tracer file from the Netherkit site, and as I go through this video, you from time to time you watch the video, pause the video, and you go through the configurations yourself, trying to make sense of what we are talking about, or what I'm talking about here in the video. Okay, so basically three ways that we can configure static routes in any particular network. So in this packet tracer network, we can see that we have three routers: router 1, router 2, and router 3. Now at the moment you may see that all the links seem to be all okay, but in fact if we were to test the network connectivity between router 1 and router 2, we may notice that although they can see each other, router 1 may not be able to communicate with the LAN that is connected to router 2. Okay, so let's have a look at the routing table on router 1. So if I type and hit enter and enable show IP route. Okay, show IP route. That shows me the routing table. Okay, here's what this all means. Notice that we are able to see that there are about two directly connected networks. That's the LAN and then the serial link between R1 and R2. Now in this case R1, if we ping from R1 to R2, okay, let me see, R2 has an IP address, that's this interface I'm referring to, serial 000. So I'll ping 172.1.31.1.193, hit enter. Okay, notice that success rate is 100%, 5 out of 5. That means that router 1 can communicate with router 2, ping is successful. But let me see if we can ping the LAN here, the LAN. Okay, so let's try, let me see what's the IP address of PC2. So PC2 has 31.0.254. That's the IP address of PC2. Okay, so I'll ping 172.31.0.254. Okay, looks like it's not going to reach. The message is not going to reach PC2. Okay, so there we are. Success rate is 0%, 0 out of 5. That means that router 1 is able to see router 2, but it's not able to see the LAN. So what does that mean? Okay, so there's no static entry here. Okay, if we go back to our show IP route routing table here, notice that routers are able to see each other. We can ping from router 1 to router 2, but we can't ping to the router 2 LAN. And that's because router 1 does not have an entry in its routing table for the router 2 LAN. Of course, we can see 31.1 here, which is pointing to its own LAN, as well as the serial interface, but there's no 31.0 entry here. So it does not have an entry in its routing table for the router 2 LAN network. Now in this instance, we can configure a static entry. So static entry, we can configure the static entry in 3 ways, using one of the 3 types of routing entry configuration. We could use a next hop route. We configure a next hop route. We could configure a directly connected static route. We could configure a fully specified static route. Okay, so what I'd like us to do in this video is we'll go step by step and have a look at the 3 methods of how we can be able to configure static routing. Okay, so first of all, let's try using next hop route. Okay, so in a next hop route, only the next hop IP address is specified. Okay, so the exit interface is derived from the next hop, and then the communication happens from there. For example, look at R1. So we are on R1. We have just tested that we cannot ping LAN 2, the LAN that is connected to router 2. Okay, so we are able to see router 2, but not the LAN network or the local area network that's connected to router 2. So in this case, if we were going to configure a next hop route, we will specify only the next hop IP address. Now that word next hop is basically pointing to what's your next interface or next router interface. Okay, so here in this connection between router 1 and router 2, we can obviously see that router 1 is connected to router 2 via serial interface 000. Now if we're going to use next hop route, we will specify the next hop IP address. So that means if we're going to point to router 2 network on R1, this is what we will type: IP route, and our destination is we're trying to connect to 172.31.0.0 space subnet mask is /24, so that's 255.255.255.0. Okay, so that's the network we are trying to connect to. Our keyword is IP route. Our destination is this. That's the subnet mask of the destination network. The next thing is what's our next hop IP address. Okay, so basically we are looking for this interface IP address, serial 000. Okay, so if I go to router 2 and then I type enter, enable show IP int brief. Okay, so IP int brief, and this is the IP address we are looking for, serial 000, and that's what we need. This is what we need, 172.31.1.193. Okay, so I'll copy this, and that will be our next hop IP address. Okay, so that's the first one. So if we were going to configure a next hop route, we only specify the next hop IP address. Okay, so from router 1, if we are going to communicate with the LAN that is connected to router 2, our entry will be IP route, our configuration will be IP route 172.31.0.0, which is our destination, with the subnet mask as this, and with the next hop IP address as this. Okay, so that's basically how we configure a next hop static route. Now let's see how a packet forwarding decision is going to be made by router 1. Okay, so we go to router 1. At the moment, you should know by now that if we type show IP route, we haven't configured any static route yet. Okay, so you've seen this line of command. Let's go config t, IP route, and our destination is 172.31.0.0. Leave a space, subnet mask 0, leave a space, and we specify the next hop IP address, which is going to be 172.31.1.193, and we hit enter. Okay, let's confirm. So by the way, if we type show IP route, it will not allow it because we are in the global config command, global config mode. To bypass that, type in the do keyword, show IP route, and there we are. Okay, so we have a static entry. We have a static entry here, and it's pointing to 31.0.0 network via, that's the next hop IP address. Okay, so this is what's going to happen. Before any packet is going to be forwarded by router 1, the routing table in router 1 must determine the exit interface to use to forward the packet. And the process, when all of this is done, this is referred to as route resolvability. Every time the route has to process any routing table request, okay, or try to determine which route it has to resolve, where it's going to send the packets to. Okay, so for example, using this information we have here in the routing table, let's take for example when a packet is destined for 172.31.0.0 network, which is that same network that's connected to router 2. What will router 1 do? Okay, so when that packet comes to router 1, router 1 will first of all look for a match in the routing table. Okay, so it looks for a match in the routing table and find that it has to forward the packets to the next hop IP version 4 address, which is 172.31.1.193. Okay, so it notices that this is where it's supposed to forward the packets to. But every route in that references this network, there's nothing here that's pointing to 1.193. Okay, there's no network here. It has to find out where it's supposed to forward that. Okay, so what that means is, once router 1 looks up its routing table, the first entry it comes across is this static entry here. Okay, so it notices that this is the exit interface it's supposed to use. Okay, so every route that references just only the next hop IP version for address and then does not reference an exit interface, it must have the next hop IP version for address resolved using another route in the routing table that has an exit interface. So what does that mean? Now that it has found out this is where it's supposed to forward the packet to, now it's going to check, okay, which network via which interface am I going to go to. Okay, it looks at the next entry, okay, not this one. It looks at the next entry, not this one. It looks at the next entry, and this is what it's going to use. So it's going to use the 172.31.1.192 network, and this will be the exit interface it's going to use. So notice that it has looked up the routing table twice. Okay, so it actually takes two routing table lookup processes just for router 1 to forward any packet that's destined to 172.31.0.0 with /24 network. And when the router performs multiple lookups in the routing table before forwarding a packet, this is performing a process that is known as a recursive lookup. We can already know what it means by recursive lookup because it's doing this twice. And recursive lookup consumes router resources, and should be avoided at all costs and whenever possible. We do not want the router to go back and forth between the routing table and try to look up all the entries. It can be time consuming as well. So a recursive static route here in this case is valid because it's a candidate for insertion in the routing table only when the specified next hop resolves either directly or indirectly to a valid exit interface. So in this case we can see that this network goes out via this interface, so that's fine. There's a valid exit interface there. But if the exit interface, which is this interface, is down or administratively down, then the static route will not be available in this routing table, which means that even though we have a static entry here, it will not forward the packet because it does not know where to send the package to, and the second recursive loop will not resolve successfully to an exit interface. Okay, so we will still be able to forward the packet. Okay, so let's test this. Let's go back to R1. Remember, earlier on we pinged to PC2. The response was not successful. Okay, so let's see if this time the response is going to be successful. Okay, I'll check the IP address again. It's 0.254. Okay, so let me go back to this router and I do ping 172.31.0.254. hit enter, and yep, it's successful. Okay, so notice that it's successful. So pinging success rate is 100%. That means router 1 is now able to reach router 2 LAN, but it was all possible because of recursive lookup. Now again, take note that these recursive lookups consume router resources and should be avoided. So what's the next possible method we can use? So the first one we used was next hop route. The next thing we're going to look at is using directly connected static route. Okay, so here we're going to specify not the IP address, but rather the exit interface. Okay, so instead of specifying the IP address, we're now going to specify the router exit interface, only the router exit interface. Okay, so let's have a look at this. Again, we're still using the same example between router 1 and router 2. So let's go back to router 1. We go conf t. We're going to remove the existing route entry, static route entry. So I type no IP route and 172.31 31.0.0.255.255.255.0. So that removes the route entry. So let me confirm that by doing a show IP route. Okay, so that confirms it. I have just removed the static entry, so we no longer have a static route now. Okay, so now we're going to use a directly connected static route instead of a next hop route where we specify just the IP address. Okay, so when configuring a static route, the next option we are using here is to just specify the exit interface of the next hop rather than the IP address. Okay, so we go to, before we configure this, let me just write the command down here. Okay, so this is what you will do. IP route, we're going to the same destination, 31.0.0.255.255.255.0. So that's our destination, that's the subnet mask. And this time, rather than specifying only the next hop IP address, we're now going to specify only the router exit interface. Okay, so router exit interface does not mean this interface, router 1's exit interface, no. Okay, rather we point to the next hop. We point to the next hop exit interface. Okay? So we use that exit interface instead of the IP address. Okay, because we know that router 1 is already able to see router 2. Okay, so we will specify exit interface as S000. Okay, so I hope this is making sense here. Okay, so instead of specifying the IP address, we are now specifying this interface instead. Okay, so let's bring this in. Let's bring that command into the router. Okay, so we go IP route 172.31.0.0. That's our destination. Subnet mask is 255.255.255.0, and we specify the next hop exit interface, which is S000, and hit enter. Okay, notice that there's a message that comes up here saying default route without gateway, and if not a point-to-point interface may impact performance. Now